setup. Hello? Hello?
Yes, sir.
Yes, sir.
Hello? Hello, Aditi? Hello, Aditi? ज्वाइन कर लो. हाँ, और प्रीतम को भी बोलो ज्वाइन करने के लिए. She is joining. She is joining. Just wait for a few minutes. And now our idea in this exercise is that as you know, I have already discussed with you that Dickinson, a famous sedimentologist, what he tried to identify that based on petrography and the modal analysis of the different, it is done basically for coarse arenaceous rocks. You must understand that for argillaceous rocks like shale, this is not valid because you cannot identify the mineral in thin section. Basically, in a shale, we try to identify by means of XRD data. Okay, what are the kind of clay mineral that is present in the shale, and then we interpret that. But in case of sandstone, in case of the granule-rich sandstone, coarse grained sandstone, medium grained sandstone, fine grained sandstone, we can do the modal analysis. So in modal analysis, what we do that we identify the percentage of quartz, then monocrystalline quartz, polycrystalline quartz, feldspar, lithic fragment. So there are 4 major types of constituents depending on the classification scheme. That is the quartz, feldspar, and lithic fragment. Now quartz again can be differentiated into monocrystalline and polycrystalline. And based on the total monocrystalline and polycrystalline, we get the total quartz, that is called QT. That is the total quartz. Now, this total quartz, so you can do the plotting based on the monocrystalline quartz, feldspar, and lithic fragment, or you can do it on the basis of the total quartz, feldspar, and lithic fragment. So one is the QMFL diagram, another is QTFL diagram. Okay, so based on that, there are some fields that has been identified, and those fields are identified either as Creton interior, the marginal arc, the continental arc, the basement uplift. So all these different fields, that it is a passive margin, it is an active arc, it is all these different fields that has been assigned into this triangular diagram, and you plot. Now, when you plot, you measure 50 grain. 50 grain. So within 50 grain, suppose you got 30 grain quartz, 15 grain your feldspar, and 7 grain as a lithic fragment. Now, how you plot that in this? First, you have to do what you have to transfer all your measurement to 100%. So when I measure it from 50 grain and do that, this is 35, this is 15, this is this, then we have to transfer it to the 100%. That out of 100%, actually how many are quartz, how many feldspar, how many lithic fragment. Okay, and then how we plot it, that Aditi will explain by showing the triangular diagram, and how we do it, that she will explain. But before Aditi comes in this thing, there are certain I should also discuss that the basic definition and the caveats that is in this entire exercise. Caveats. That what is a sand? Sand is a size, as you all know. That is 2 to 1 by 16 mm. That is sand. Okay. Then 1 by 16 to 1 by 256. That is a silt. Less than 1 by 256 mm. That is the mud. So all this, the size analysis we know. Now, as we discussed earlier, should a sand be essentially a silica or quartz grain? No. Anything which is in this size is a sand. Suppose when I get, a feldspar, that is also a silicate, a carbonate even, it can supply a sand size grain. So I can have a carbonate sand size grain. Fine. So sand size grain that is irrespective of any, that whether it is silicate, whether it is sandstone, whether it is carbonate. So we get the sand size grade that is derived from any provenance, whether it is a silicate provenance, it is a carbonate provenance, I can have the sand size grain derived from that. Now the question comes that when we talk about the sand grain, then there are three different. That is what we are saying, that the quartz, feldspar, and lithic fragment. Now, what is the distinction between a lithic fragment and a mineral like quartz and feldspar? Because lithic fragment is essentially a rock fragment. Now, a rock fragment, it can be an igneous rock fragment such as a basalt. But can I have a granitic rock fragment? No. Why? Because granite is a coarse grain plutonic rock. Now, a coarse grain plutonic rock, because there are coarse grain, so in case of its transportation, individual grain gets separated. Individual grain gets separated, so you get the separate quartz and feldspar grain when a granite becomes a supply. But think of a basalt. If it is supplied, then what basalt will do? Basalt is a volcanic rock and fine grain volcanic rock. So when you have a fine grain volcanic rock and that basalt is supplying sediment, definitely there is no question of these microlites of feldspar or pyroxene that get separated. That never gets separated because it's a fine grain rock and that remain in the matrix. So the basalt will essentially supply the lithic class. It will not supply individual pyroxene or plagioclase. No, it will not do. All fine-grained volcanic rock, they basically supply the lithic class. They never supply a mineral grain. Whereas a plutonic rock always supply a mineral grain. So this is a fundamental distinction, that the lithic class are necessarily to be fine grain, whereas the minerals, they are essentially supplied from the plutonic rocks. If igneous rock, I consider the primary rock which is deriving the sediment. Now sediment can also be derived from an earlier sedimentary rock. Now, when there is an earlier sedimentary rock and it has become a supply for the next sedimentary rock, that I have already discussed in your petrology class, that the double overgrowth and the broken overgrowth, which all shows that they were deposited somewhere else and then again got transported. So you got the overgrowth being broken, this is being cemented. So everything this is available, that whether a sedimentary rock that is becoming as a source of the sediment. Now, this saying so, suppose there is a basalt, okay, and then above that basalt there is a weathering profile. I believe that you people can, you are getting my point, what I am saying?
Yes, sir.
Suppose there is a basalt and there is a weathering profile on that. Now, what you get in that weathering profile? In the weathering profile, you are getting that the basalt is weathered and it is supplying the clast, but that clast is a lithic clast. That clast is a lithic clast. No way it can be a separate grain that is there, and if it supply that, then you will get in form of a lithic clast in the sand body. Yes, a basalt can also be a provenance, but it will always supply a lithic clast. Now, I was also asked just 2 days back by Aditi that when a chart, suppose a chart. Now, what is chart? Chart is a fine-grained siliceous rock. We have discussed how chart is formed and everything. Now, what is a quartzite? Quartzite is also a siliceous rock that is full of quartz. Fine. So think of a quartzite, then think of a chart. Both are full of quartz. In one case, the quartz grains, they are of coarser size. In one case, the quartz is microlithic quartz. They are very fine grain quartz. Now, what we do, when quartzite becomes a supplier, it will supply the simple sand grain. But when chart is supplying, it will supply a lithic clast. Because chart is a fine grain. As I said, all fine grain rock, they basically supply the lithic clast. Now, chart is a lithic clast. Now, suppose I have a siltstone, which is a siltstone, which is also made up of quartz. And there is a chart. Now, if there is a siltstone and there is a, both are basically lithic clast, a siltstone clast and the chart clast. Then the question may come, that up to what extent I will say that the chart is a lithic clast. Suppose I have the quartz, as you see in the thin section, there are quartz sometimes in a very fine grain, sometimes it is slightly larger grain, and sometimes the quartz is really large grain. Now, up to what extent I will call it a lithic clast? I will call it a lithic clast as long as the size, there is a size limit of the constituent grain of the lithic clast, which basically define that what will be the boundary when I call it a lithic clast. If the size of the subgrain is below that boundary, I call it a lithic clast. If it is more than that boundary, then I count it in form of a mineral. Am I clear what I am saying? It is the size of the subgrain of a lithic clast that will define that whether I will call it a lithic clast or I will call it a mineral grain. When I do the modal analysis, then what I do, that modal analysis, there is an instrument we attach with the microscope. And then we actually, there is a cross. That cross moves on the slide, and when we press the button in that instrument, that cross moves on the because it is all online physical. When I say, I would have shown you that how it is done. Then the cross moves on the slide. Now, if two successive press of the button, that cross remain in the same grain, that means the size of the grain is significantly large. And in that case, I will not call that grain as a lithic clast. But if two successive press of button, that the cross, it shifts to the next grain, that means that I am in a lithic clast, and it is a really small grain of that class, so that I can make it a fine grain rock derivation. Okay. So with this background, I will now ask Aditi, and we will discuss in course of this exercise. If any question come time to time, we will discuss. So I ask Aditi to project the triangular diagram and describe how to plot, and also tell the problem what they will do.
Okay. Thank you, sir. I will start sharing the screen now. So, the screen is visible to all?
Yes, it is visible.
Okay. Yes, sir. So, sir has already explained what is the provenance analysis and how do we do it. These are the two diagrams that we use, QTFL and QMFLT. So QT is quartz total in this diagram, if you see. And these are this work was done by Dickinson earlier in 1979, and he described all these fields. So we calculate, as sir has explained, we calculate the grains or the clasts, and then we convert it to the percentage, and then we plot it in these two reference diagrams that are given by Dickinson. So here QT is representing the total quartz, in which we consider all the quartz as monocrystalline. If we are getting monocrystalline quartz, polycrystalline quartz, and so we consider both together as total quartz. If we consider this diagram, QMFL, So QM will be your monocrystalline quartz, and other polycrystalline quartz or chert, if it is of significant larger class size, having larger mineral grains, then we will consider it in the lithic grains. So that will be in the lithic fragment category. So we'll see that how we use this triangular coordinate plot. For this, we use a triangular coordinate paper where we like, as you see that these fields are defined as this is demarcating the quartz, this point is demarcating the feldspar, and this is for lithic fragments. Okay, so if I see this is a triangular coordinate paper, so how do we assign the x's and the marks or the data values to these paper? We'll see. This is marked as quartz.
Just come in 1 minute.
Yes, sure.
Students, what she is now describing, you go to the back slide. Yes. Now this is the quartz feldspar lithic fragment. Now there you can see in this diagram there are 3 vertices, that is quartz, feldspar, and lithic fragment. Now question is that if you see that there are certain fields that Dickinson has marked, that is craton interior, transitional continental, basement uplift. So first you have to, in the triangular diagram, you have to mark the field. Unless you mark the field, then how you will plot it and then know? Because the marking of the field, that is very, very essential. Because you have to first, you get my point, students?
Yes, sir.
Yes, sir.
Yeah. So now she is describing how, suppose how we mark craton interior, on what basis, transitional. So that you first listen to her and then you try to understand before we go to the problem, how we mark the field. This is what she is describing. Okay, Aditi, you go on.
Okay, so this is the triangular coordinate paper in which we see that this point is assigned as quartz, and this is for feldspar, and this one is for lithic fragments. So first we divide the paper. If we see that we consider that quartz is 100% at this point, and if we go away from this point, the percentage quartz percent, we take the values in percentage. So here the quartz will be 100%, and as we go away from this point, your quartz, you can divide the scale as per your convenience or as per your needs. But as we take it in the percentage, I'm dividing it from 0 to 100. Okay, so here the quartz will be 100%, and if I go here, your quartz value will decrease to the 90%, then to 80%, and as you go downwards, you will get 0% quartz on this line. Okay, so basically these two axes, this axis and this axis, in the triangular coordinate plot, two axes represent one single type of the grain. Means your quartz will be represented by this axis, will be represented on this axis also, and on this axis also, on both the axes. Is it clear?
Yes, ma'am.
All right. So if we see for the feldspar, okay. So this is your this point is assigned for the feldspar. Okay. So here your feldspar content will be 100%. As you go away from this point, your feldspar will be 90% at this line. So if you for feldspar, the two axes you will get, one will be this axis and one will be this axis. Okay, so here you will get 90% feldspar. If I show you this, you will get 90% feldspar here and 90% feldspar here at this point. Okay, similarly, as you go away from this point, this line will be representing 0 feldspar. Okay, 0% feldspar from here to here. Okay, so these two axes will be representing your feldspar content. Similar will be for the lithic fragment. Okay, this is your lithic fragment, and if this here it is 100%, and as you move away from this point, your feldspar, your lithic fragment percentage will be 90% here, then it will be 80% and 70%, 60%, and as you go away here, you will get 0% of lithic fragment. Okay, so if we see that quartz is ranging from 100 to 0 here, so these two axes will represent your quartz percentage. These two axes, this one and this one, will represent your feldspar percentage. As your feldspar content is marked, you can mark your feldspar content at this axis also and here also. And these two axes, this axis and this axis, will mark your lithic fragments. Okay. So these are the fields that were characterized by Dickinson. So we'll see how do we mark these fields in the triangular plot. Uh, Up to here, is it clear now? How do we define the axis for the quartz, lithic clast, and feldspars?
Yes, ma'am. Yes, ma'am.
Okay. So this is the triangular coordinate paper. Okay. And uh, here, these are the fields defined by Dickinson. So if I consider this is your quartz, okay, this will be your feldspar, and this will be your lithic fragments. Okay, so we see that on this axis, here we'll start one by one. Okay, so if I consider this line, this 3 to 15 line, okay, so you see that this axis and this axis, these two are representing your lithic clasts. Okay, so if I have to mark 3 here, so I will consider that your lithic fragment is 100 here. It will be 90 here if I divide it like this, and this will be your 80, then this will be your 70. And as we go here, you will get 0% lithic fragments at this point. Okay, so your lithic fragment will be 10% here. Okay, so each division, each smallest division is representing 1%. So this will be your 1%, this will be your 2%, and this point will be your 3%. Okay, and if we come to this axis, here it is written as 15 percentage. Okay, so your lithic fragment will be 0% as this at this point. It will be 10 at this point, and then 11, 12, and 13, 14, and 15. You will get 15 at this point. Okay, so now what we'll do, we'll join 5 to this 15 to 3. Okay, is it clear up to here?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, all right. So now if we see,
So now Aditi,
Yeah.
so you have already told how to do it.
Yes,
Let
sir.
them do it. Okay.
Okay, sir.
Rest of the things, let them do it. We
Okay,
will
sir.
not tell all the things.
Okay, sir.
Okay. So
Yeah, yeah.
students, already she has described that how to do it. Now you have this figure. This will be, you already have taken a printout of the triangular. And then this, I will ask her to remain this classification triangle projected. So you now classify all the fields. If any problem you ask, okay? Okay.
Okay,
Is
sir.
it okay with students?
Yes, sir.
Yes,
Yeah,
sir.
please do it. And once you do that, then we'll come to it.
Excuse me, ma'am. Ma'am, can you project the first slide?
Hello.
Which one?
On the first slide, the classification I know.
Okay, this one.
Yes, ma'am. Yes.
Yes, ma'am.
So first, sir, like what should they plot? QTFL or the QMFL diagram?
Hello. No, you first identify the QT. We'll do the QTFL diagram first, then we'll go to QM because that is a different field. Little.
Yes, sir. Okay.
First, do the QT.
Okay.
क्या हुआ? अच्छा जमा कर रहे हो? अच्छा ठीक है, जमा लेगा आज? अच्छा ठीक है, करके मेरे को कॉल कर दे। नो जोगेश, मैं क्या बोलूं, unless you were there it would have been not possible by that boy to submit. I am telling you. ना मैं नहीं राजेश अभी जमा कर रहा है। हाँ साइंस कमेटी अभी जमा ले रहा है मेरे को।
Mom,
Yes.
the 18 value in QTF line, it is projected from which point in QTL?
uh, it is 18 value. Okay, if you see, you have 100% quads here. So on this axis, na, you will have either quads or feldspar. Okay, so if you are having 100% quads here and 0% quads here, you are divided the entire field equally. It is not possible to get 18 for quads here.
That ये मेरा मानना है। I am sharing with you that if there is a suppose कोई बच्चा एडमिशन, अभी सपोज इसी के साथ ही ये हुआ है, ये जो है ये जाके उसके साथ शायद वो जमा नहीं किया होगा। That is I am saying. So ये तो बच्चों से हो ही सकता है ना। तो ये जब there is a rule and regulation and accordingly that we will keep all the record and एक बच्चे के नाम पे वहाँ हम लोग क्यों नहीं भेजते?
So if you see from the feldspar, you are having 100% feldspar here and 0% feldspar will be at this line.
ये प्रॉब्लम तो किसी के साथ।
Hello. Hello.
Yes.
Okay, so now is it clear? Like this, if you this 18 could not be for this quads. No, you are having 100% quads here, so it will not be for quads. If you see, for this axis is for either representing quads or feldspar. These two options you have. Okay, so if you see for the feldspar, this will be 100%, this will be 0%, and if you go from here to here, you will get 0, 10, 20. Okay, so this 18 is for the feldspar. This is how we see, like for 37 is for what, 25 is for what. This is how we define different fields. Okay.
Ma'am,
Yeah.
the value for 18 on the QTL, ma'am, I wanted to ask that.
Which value?
मैम वो 18 से प्रोजेक्ट करेंगे ना किसी और लाइन पे.
Okay, here, okay. No. You do not need the other value. आपको triangular plot में you have these x's, okay? So that 18 will be the parallel to the axis. As you see that this line is not parallel to the axis. It is joining 3 and 15, okay? But this 18, you will plot it as parallel to these axes.
Okay, ma'am.
Just parallel to this axis.
Okay, ma'am. Thank you, ma'am.
मैम हो गया.
Okay. सबका हो गया या किसी को कोई कंफ्यूजन है? If anyone have any doubt, you can ask.
I'm done.
Okay. Hello, sir.
Yes.
Sir, they have defined, marked all the fields. So,
All the
shall
fields they
we-
have marked.
Yes, sir.
Okay. Then they ask them to, if they have 2 sheet, do they have 2 sheet or 1 sheet only? Students, you have 2 sheets or 1 sheet only?
So we have.
Sir, we have to see.
2 sheets. So if you have 2 sheet, also plot the next.
QMFL diagram also.
So QMFL, that also you plot.
Hello. This students, one girl was asking like, how do we keep this 18? Na? This will be parallel to this line, okay? You have this line of 45 to 25. Na? This 18 will be parallel to this, and similar for this 20. This line will be parallel to this 13 to 43 line.
Okay, ma'am.
Ma'am, what about the 13 line?
Which one? This?
No, ma'am, other one.
Huh?
Which one? 13. This 13.
13, 18,
Only
29,
13 in diagram. In the base different.
47. Hello?
Yes, sir. Hello. Sir, she is asking like where to join this 13 line. Is it now? I think it is up to 20.
There the intersection is not marked.
Yes, sir. Yes, sir.
Yeah.
So,
So,
sir,
yeah.
it is actually joining this. It is going up to this 20 division.
Yeah, it is actually going up to 20, and in between they have not drawn the line.
Yes.
Okay, ma'am.
আমরা ফুটবল চাই, আমরা একটা ভালো টিম চাই। প্রত্যেকবার হাত থেকে আপনাদের টিম করবো কিনা, খেলবো কিনা, ওটাই বুঝে উঠতে পারি না। আলটিমেটলি তো এই লক্ষ্যটা আমরা মনে রাখবো। ফুটবল খেলা কিনা সেটাই বুঝে উঠতে পারি না, সেইটা পরে শেষ হবে। এটা তো চলতে গেলে 18 বছর পর আমাদের কানে কোনো মনে গতি নেই।
Ma'am,
Yes.
ma'am, how we will project the line from 42 and 29 on QMLT line?
Yes. If you mark the point 50 here, and if you join that 50, the 50th division with the feldspar, you will get a line. Okay. So parallel to that line, you will plot these two lines, 42 and 29.
Okay, ma'am. From the line 50 to F.
Yes. If you
Okay.
plot a line, you will F 100% F to 50 here. 50% quads or 50% lithic fragments. You will get a division here 50. Okay. So parallel to that line, you will plot these two lines, 29 and 42.
All right.
Ma'am, for the 47 value in the FL line, ma'am, is that for F or L?
This if you if you divide this line equally, you will get 50 here and then there. Okay.
Yeah.
So for lithic fragments, this will not be 47. This 47 will be for feldspar. This line is representing both lithic and feldspar. This will be for feldspar. Because your 50 will be somewhere here. Okay.
Okay, ma'am.
Okay.
नहीं नहीं, मेरे को ये वो तो वहाँ रखा हुआ था ना डिपार्टमेंट में। ये मेरे पास क्यों आएगा? मैं देखता हूँ मेरे पास कैसे होगा मेरे को समझ में नहीं आ रहा। नहीं तो एक बार साइन कराना पड़ेगा क्या? यस नहीं है, वो ऑफिस में दिया गया, मैं तुमको दे दिया होगा, तुम्हारे टेबल के ऊपर पेंट करो।
मुझे दे दिया मैंने, एक्चुअली मेरा डेट था तो मुझे नेट था भाई नेम को एक्सटेंशन
तो डेट का साइन हो गया था,
डेट का साइन हो गया, मेरे पास कॉपी है उसकी,
हाँ
साइन हो गया
तो और
उसके बाद कॉपी का मैंने नंबर डाला उसके ऊपर,
नहीं मेरे को दिया,
ये नंबर डाला, सर्टिफिकेट प्रीसिमेंस नंबर राजेश,
हाँ
उन 5 साल को,
हाँ तो ये तो भेज दिया होगा उधर,
नहीं अब यहाँ स्टार मार्क करके लिखा हुआ है, ओरिजिनल हैंडेड टू प्रोफेसर
ना ना नहीं, कविता सही लिखा, उस दिन साइन होने के बाद कविता मेरे को दिया था, फिर अगले दिन मैं तुमको दे दिया था, तुम्हारे हाथ में मैं देके आया।
साइन कराने के लिए तो मैंने
ना उस दिन तुम आए नहीं, उस दिन तुम आए नहीं थे। तुम सुनो ना मेरा बात सुनो। उस दिन में ये है फर्स्ट दिमाग का, ये तुम्हारे टेबल पे था, तो मैं बबीता के पास गया कि बबीता फॉर्मेट किया, तो बबीता तुम्हारे टेबल से हर्ष दिमाग का ये मेरे को दे दिया। मैं इस फॉर्मेट में बनाया, फिर मैंने साइन किया, हेड ने साइन किया, और हेड साइन करने के बाद बबीता बोला सर आपके पास ले लीजिए, मेरे को दे दिया। नेक्स्ट डे तुम आए तो मैं तुमको दे के आया, तुम्हारे टेबल पे होगा, जरूर होगा।
जब आपने मेरे को दिया था तो एटलीस्ट साइन होने के बाद
मैम
होने के बाद दिया एग्जैक्टली।
4313 वाला फिर से एक्सप्लेन कर दीजिए।
Which one?
थैंक यू मैम।
Sorry, मैं समझे नहीं क्या बोल रहा हूँ।
मैम ये 43 और 13 वाली लाइन।
ये वाला लाइन कैसे प्लॉट करोगे?
मैम
Okay, so आप देखो ये axis, this axis is representing your lithic fragments in quartz. Okay, you have 100% lithic fragments at this point, and you will have around 90 or 92, oh, sorry, 89, 88% lithic fragments here. Okay, this 13 is actually representing your quartz percentage.
yes ma'am।
And if you see at this axis, you will have a division of 50 around here. Okay, the midpoint of this line will be here, and this line, at this line you are having quartz and feldspar both. Okay, so if you mark the divisions, you will this 50 will be for both quartz and feldspar, and you will have 60, 70, 80, 90 and 100 for quartz. So this 43 will not be for quartz. Okay, if you divide it from feldspar, 10, 100, 90, 80, 70, 60, 50, 40. Okay, this 43 then will be for feldspar.
yes ma'am।
Yeah, what is the problem?
So she was asking how do we say, how do we decide that ये 43 किसको represent कर रहा है actually?
हाँ,
तो ये 43 किसको represent कर रहा है, quartz को कि feldspar को?
quartz or feldspar is a very simple logic that if we see this whole field and this is quartz 100% and feldspar 100%, and if we come to the 50%, that is 50 feldspar and 50 quartz, then it will come somewhere here. This is the 50 line, but this line is inclined towards this direction. Okay, it is not the half of this line. Okay, so if it is inclined towards this direction, and then if it is quartz, then it will be more than 50.
Yes.
50% is somewhere here, is the half of the line. If I measure the length of the line and see the where is the half, then the half is the half 50% feldspar, 50% quartz. From there, it is going towards the quartz side, but the figure is less than 50.
50.
So it cannot be quartz. It cannot be quartz. It has to be feldspar. If the quartz would have been here, then this would have been more than 50. So if it is 43, it has to be the feldspar content that is there.
okay sir।
Or alternatively, you can say that 43%. Sorry,
57% will be a
57% quartz. You can either mark 57% quartz or 43% feldspar. It is the same point. So Aditi,
Yes, sir.
okay, is it done? They have done it.
Sir, have any of you plotted the
Yes,
code?
yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so can you project the problem?
Yes, sir. So we have the data for 4 samples here, and this is a monocrystalline quartz, then polycrystalline quartz, K feldspar, plagioclase, mica, siltstone, chert, basalt, and iron oxides. Okay, so if we see this diagram, you have marked the field as you have divided the class in 3 categories: quartz, total. We'll plot this QTFL first. Okay, so quartz total, feldspar, and lithic fragments.
Again, feldspar total.
Yeah, feldspar total and lithic fragments. So here,
Now they have to do. They will do it.
okay, sir. Okay.
हम लोग ज़्यादा ये नहीं करेंगे. Now they will do it. Process is clear to students. Hello, students. You have anything to ask? How to proceed?
Hello.
Is there
Yes,
any question that we have? Then you can ask,
Okay, sir.
or you go ahead with the problem.
Ma'am, for total quads, we'll add the mono and
Hello,
quads. So for the
you
total
please
quads,
be loud. We cannot hear you.
so for the total quads, we'll add up the monocrystalline and
Yeah,
polycrystalline quads.
mono and poly. If you add, then the total quartz you get.
Okay,
Then similarly, potash feldspar, plagioclase feldspar. If you add, you get the total F.
And all these 5 will give you the lithic fragments.
Students, is it okay? Can you able to do it?
Yes,
Yes,
sir.
sir.
Hello?
Yes, sir, we are able to do it.
Okay. So you are first transforming it to 100, na?
Yes, sir.
Okay. हेलो,
Yes, sir.
कुछ बोल रहे हो?
सर नहीं, शायद किसी ने कुछ पूछा नहीं।
हाँ, कुछ बोल रहे थे? Students, have you completed the plotting?
So one is done, second one we are doing.
In which field is it coming?
What, ma'am?
In which field are you getting this? You are getting this first sample?
From Craton Interior.
Okay.
Okay, so plotting is complete, na?
Ma'am,
Yes.
ma'am, first two temples are Cretan interior. Third one is the basement uplift, and fourth one is the transitional art. Is it right?
Okay. And second?
Ma'am, second, ma'am, telling that sample one and sample two are in the Cretan interior.
Okay. Okay. Okay.
Third sample is basement uplift.
Okay.
And fourth is transitional art.
Okay. Yes. Yes. Okay.
I'm also getting the same.
Sorry. Okay. Okay. You are getting the same.
Yes, ma'am.
Okay.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, it's the second one is coming on the line of Creton interior and the recycled one. Then
And the recycled origin.
yes, ma'am. Ma'am, on the line.
Okay. Uh, sir. Hello.
Yes.
Sir, can you please explain if a sample is coming on the line, so in which field should we keep it?
Yeah, if a sample that falls in the line, then we cannot directly assign it to either of this field. And then we write it as it is falling on the line between the two. We then tell about that this is from this to this field. So it is a transitional. Then this criteria is not alone to assign it. Then we take resort to the other method also to do it by different isotopic analysis, trace element analysis, major element analysis. So then we go to that sort. So if a sample fall on the line, then as it is falling on the line, so we'll tell that this is in a transition from this to this tectonic domain, and then we resort to the other analysis.
Okay, sir. Okay, sir. Thank you.
Ma'am,
Yeah.
then for the second analysis, means the next one, we will take only the monocrystalline quartz, then we will discard the polycrystalline, means will not take it.
No, no, you will not discard polycrystalline quartz. You will consider it as a lithic clast. Okay.
Okay, ma'am. Okay, ma'am.